Hello everyone. So today I was concerning myself with exploring how exactly Ammonite REPL works and how exactly it transforms the code that the user entered into the evaluated value. With this knowledge, it is my hope that we will be able to inject the Dotty compiler instead of the Scala 3 compiler. So first of all, I was trying to compile and run trying to compile and run Ammonite from the sources, and it turns out that in order to do so, in order to run the REPL itself, we first need to publish all the Ammonite artifacts, and because otherwise it is not going to resolve them correctly. Otherwise, I have taken this command from the README of Ammonite, and it launches the REPL itself. Today I was concerned with the question of what exactly happens when we enter a certain statement into the Ammonite REPL, right? So given, for example, this statement over here, we enter it in the REPL and it evaluates it to 15. The question is what exactly happens inside and how exactly does it do so. So in high-level terms, the following happens in the REPL. So first of all, there is a certain loop. REPL runs in a loop which reads the user input, then it compiles it, and then it evaluates the code, right? So this is pretty obvious. So the way it does so in more details is as follows. First of all, the code that the user has entered is parsed into commands, and this code, the original code, ends up as a list of statements. So if we entered only one statement, it will end up as a list with only one element. After that, the code is going to be fed into something known as the interpreter of Ammonite. It is a section of Ammonite that actually compiles and runs this line of code. So the way it does so is as follows. First of all, it is going to wrap the code that the user has entered into some other Scala code. And this code you can see here. So the original line of code ended up over here. So as you can see, we have, first of all, we have some imports, which are some predef imports, some Ammonite specific imports. Then we have an object. In the object, we have a value with the code that the user has entered. Finally, we have the main method that obviously is supposed to be executed at some point. And what it does is at some point it prints the value on the screen, the value of the user's code on the screen. And the idea is that if we run this main method of this object, object command1, then what this main method is going to do is it is going to output the result of the evaluation of this line. Next, what happens is that this code ends up compiled and executed by Ammonite. So the result of the execution of this code is an iterator of strings, and the iterator of strings would be as follows: res0 colon eval equals 50, and in this case it should probably be res1. I didn't copy it correctly because over here we had res1. So now how exactly it does so? Let's have a look at the code base a little bit. So first of all, here we have the main REPL loop, and so it resides in the REPL object, in the REPL class. So here is the REPL class, which takes a lot of configuration parameters, and there is this run method that executes the loop, and there is also this action method that is actually the body of each loop iteration. So from the loop over here, we call this action method over here. So what exactly does this action method do? So first of all, what it does is there is this call to frontend.action, and what it is it is a parser. So basically what it does is it reads the user input from the standard input, and it parses it. It parses it into the statements, into the list of statements over here, and it returns this list of statements together with code. And the way it does so precisely is as follows. So there is this read line, pretty small method. So it reads this line, it takes the code, it invokes a fast parse in this code to produce this list of statements. And so far it is just list of strings, and I assume no heavy AST processing is going on there. All right. So this is how it parses. So we are back to the action of the REPL iteration. So what happens after we parse this user input into the list of statements? The next step would be to feed these statements into the interpreter. And the interpreter is the part of Ammonite which deals with compilation, execution, and evaluation. So how exactly does that happen? So if you go to the interpreter over here, there is this process line method. So it takes the code and the list of statements. And by the way, I was trying to look up where exactly the raw code used inside this interpreter, and I was not able to find any references inside this process line. So I was not able to find any references, and I assume it is that code. But the statements is what is actually used. So if you look at this process line method of the interpreter, we can see that the processing is done in two steps. First, we have this preprocessor over here, and the preprocessor, it works on the statements, on this list of statements. And what it does is it produces the following code out of them. So it takes the original user statements and it wraps them into the objects that we have discussed previously, the objects with the methods that can be executed and output something to the command line. So talking about the preprocessor, in my explorations, I found an interesting part. So at first I was assuming that it doesn't deal with the Scala compiler at this point, but when I looked in details at the code, so it lives this preprocessor generation code. It lives in the compiler lifecycle manager file, and it turns out that it does deal with the compiler. So let me see if I can find any compiler mentions. So I cannot find them in the constructor, but if you look at the preprocess method itself, it uses the compiler in the construction of default preprocessor. So here we have compiler.parse file name, and if you look at this parse method over here, so we have the references to the compiler. So this is the interface. And already in the interface, we can see that it deals with global trees, and global trees they come from NSC. So NSC is the new Scala compiler. It is the compiler of Scala 2. So basically, already at this point, if you want to inject .i, we will have to replace to replace it, to start replacing it over here. And that's the first place where we will encounter it. Right, so after we have obtained the following code, the following wrapped code, the next step to do would be to compile it. And the way it happens is in evaluate line method. So let's have a look at what exactly it does. So evaluate line, it is defined right next to the logics that we have been discussing, next to the process line method. And evaluate line, so what it takes is it takes this processed output, which is the wrapped code that we are working with, the file name and some other stuff. So what it does is first it invokes a compiler on the processed output, and then it invokes the evaluator, so eval.processLine, on the result of the compilation, and the result of the compilation, as you can see here, is the class files. So the idea is to compile the code to the class files and then evaluate it. So let us have a look at the evaluator first, because it is more interesting, I think. The compiler is, pretty straightforward. It just compiles the input to the classes, and the evaluator, let's see what it does. So what we need here is evaluator. We need the implementation, because previous process line over here, it is an interface message, and process line over here, it is actual implementation. So it takes these class files, and what it does is, so it takes the class files, it attempts to load a certain class file, and my assumption would be that this certain class file would be this session name, would be the session name class. I cannot see it defined over here, but probably it either comes from, I think it comes from the package. So here we have this imports section, and it actually, it contains a lot of imports, and I assume there are also some package definitions, package statements, and the package statements must have this form, index wrapped name class files. So I haven't examined these variables, but I assume that what they do is they point us to this object over here. So what happens next is that we call this evaluate main function on this class, and what it outputs is this. So this call is over here, and it outputs an iterator with evaluated code. So basically it executes the user code this way, and it obtains the iterator. My assumption would be that the iterator comes from this print statement, so it must be something like printing this result into some kind of output stream, and then taking the tokens that it generated as an iterator. So before we wrap this video, I would like to examine this compile class method again, because obviously that's going to be the most interesting method if you're going to use the Dotty compiler instead of Scala 2 compiler. So it is defined in the compiler lifecycle management, and it is this file is already familiar to us because we have seen this preprocess method in this file, which generates a preprocessor, which actually does the work of producing of wrapping the user input into the object. And this is a compile class. So compile class method, and it invokes the compiler. So let us see maybe where is this compiler. So yeah, so the compiler is let me just locate where it is defined. Compiler. So this is the Ammonite compiler. If you look at this compiler, it is a wrapper around the Scala 2 compiler. So NSC is the Scala 2 compiler, new Scala compiler, and it invokes this compilation method, compile. So let's see what it does. So yeah, so what it does is it produces a compiler run using the Scala 2 compiler, and then it invokes compile files on this run. So my assumption would be if we want to inject DOTI to compile the user input with DOTI instead of the Scala 2 compiler, we will have to inject somewhere here as well. So that was the preliminary investigation of how exactly Ammonite pipeline works, and we have located some points in which we might want to inject the DOTI compiler instead of the Scala 2 compiler. So I think a good strategy to proceed from here would be to compile the Ammonite with Scala 2, yet teach it to learn, teach it to work with the DOTI compiler, to compile files with the DOTI compiler and see what happens.